Okay, guys, let's take a look at measures of location and box plots. In this lesson, we are going to introduce another measure of spread and also decide when an observation is or is not an outlier, which is actually pretty important. Now, why do we need one more measure of spread? Well, in last lecture, we talked about the range, which is the difference between the largest and the smallest value in your data set, and standard deviation, which was measuring approximately average spread of the data from the mean. But remember that both of these measures, the range and standard deviation, are actually not resistant to outliers. What does that mean? It means that if you have an extreme observation, like an outlier in your data, then those measures will be really biased. They're going to be biased towards that outlier. It's going to skew them, which we don't want. And that's why we need one more measure. But first, we're going to talk about percentiles. Now, you might not know it, but actually you already learned in this course one specific percentile, which is the median. The median divides the data into two halves. 50% is below and 50% is above, approximately, okay? And that's actually a special case of a percentile. Now, what is in general a percentile? So it is going to be a value, pth percentile, like 20th, 35th, whatever, such as p% of the data is below or possibly equal to it, okay? That's pth percentile. Okay, so let's say what is 20th percentile? Well, that means that 20% of the data is below or possibly equal to it, and 80% is above. Now, sometimes it's hard to find these percentiles because, especially for small data sets, you might not be able to isolate like a group that has exactly 20% below and then 80% is above. And so it's just always approximate, okay? Let me just give you another example. Let's say you've got a report back on how you performed on the SAT and you are in the 70th percentile. What does that mean? Well, I want you to remember that this 70% is the percentage below or like you, or the same, not above. Okay, sometimes people make that mistake. So 70th percentile means that 70% of the data is below you or possibly equal, which means that 70% of all individuals who took SAT did worse than you or like you, and 30% scored better than you. Now, we are going to specifically talk about quartiles. So forget about all percentiles, like a 21st percentile. Who would ever use it, right? But the quartiles is actually something very important. We are going to divide our data into quarters. Well, quarters, there are 4 of them, right? And then when we do that, we're going to find these quartiles. Okay, so what is the first quartile? Now, it's denoted by Q1, and that is actually the same thing as the 25th percentile. So that means that 25% of the data is below and 75% is above. Again, what happens when it's actually equal? That's included in the bottom part. The second quartile, which is actually also the median, so now the median has another name, it's also second quartile, and it even has a third name, which is the 50th percentile. Well, that divides the data in 50% is below, 50% is above. And you probably already guessed what is the third quartile, or Q3. That one divides the data into, again, 75% this time is below and 25% is above, and it's denoted by Q3. All right. Now, I have this picture that is kind of, it's AI generated. I'm not really sure I particularly like it because it's kind of weird the way it drew this circle in the middle. I don't know what that means. Anyway, I just asked it to help me help you visualize the quartiles. So think about the data divided into 4 quarters, right? And let's get a little bit closer to this plot. What happens? So the bottom 25% has these blue dots. That's still Q1 divides 25% versus the rest of the 75%. Then you got another 25%, another 25%, and finally the largest 25% in your data. Okay, so there is Q1, there is Q3 for you. This is the median in the middle right there. Now, the distance between Q1 and Q3, as you can see over here, this distance right here, from here to here, this is called Interquartile Range. And we're going to abbreviate it as IQR, Interquartile Range. Now, here is where you get your note card that you get ready for the test. And this is what you write on your note card. What is IQR? It's Q3 minus Q1. I never will give it to you. And I will, of course, ask you on the test what it is. So if you are given the quartiles, how do you find the IQR? You subtract the first quartile from the third quartile. Because the third quartile is always larger, you can never get a negative number. Okay? So this is going to be that interquartile between the quartiles, and it's interpreted as the range of the middle. What percent? Well, what percent's in here? 50%. This is the range of the middle 50% of your data. That's IQR. Very, very important. Okay, how do we compute quartiles? Now, this is what they do. Something like Desmos. What they do is they sort the data in ascending order from smallest to largest. They find the median, which is like in the middle, right? Then they divide the data in half using the median. Half of the data is called bottom half. The other half is the top half. The first quartile is the median of the bottom half. So you take in the bottom half and again dividing that in half, and the median of the bottom half is the first quartile, and then the median of the top half is the third quartile. Okay? Now, this not including everyone has a different definition of quartiles. If you see what Desmos does, or if you see what Excel does, and there's like every software has a special way, and not to mention something like R, which is a sophisticated stats software. Everyone gives different answers. So what we are going to do is we're just going to stick with Desmos. Desmos is going to give us the quartiles, and that's what we're going to use. Now, how does it do that? Let me just show you real quick how it does that, and then I'll show you the functions that you can use to compute them. Let's say you have these 10 students and their GPAs. What Desmos will do for you, you don't have to do that. It'll sort the data. Okay, so it'll sort it. And then it's going to divide it in half. So let me show you. Okay, so you sort the data, right? You have 10 observations. Where is the median? Well, 1, 2, 3, 4, 5. So this is going to be like right here. So the median would be this Q2. This would be the average between 2.53 and 2.71. That's the median. And then for the bottom half, which is the left side, right? We find the median again. And in this case, it's going to be this one right here, right? That's going to be your Q1. Okay, that's 1.9. And then for the top half, then you're going to get this number right here. That's going to be your median of the top half, and also that would be Q3. So your Q1 is 1.9, and then your Q3 is 3.33. Okay, so with that said, let me show you how to compute the quartiles in Desmos. Okay, so here I have Desmos calculator, and I just copy-pasted. Let me just make this a little larger. I copy-pasted the data into Desmos, which by now you should know how to do. Okay? To compute quartiles is super easy. Now, if you forget, all you gotta do is go to the keypad. So look on the bottom. You go into the keypad right here. You're gonna go to functions, which are right here. And then you're gonna scroll just a little tiny bit so that the statistics functions are here. And look at this. The quartile is right there. That's what you need. Okay? So you're going to put quartile and then L. And for some reason, Desmos is not giving you anything. Like it just has that triangle, but it's not telling you anything. Why? Well, because you did not give Desmos enough information, because how many quartiles are there? Well, there's first, second, and third. And you didn't tell which one. So that's why there is no output. So you need to put a comma, okay, and then tell which one. Let's say it's the first one, so you just put number 1. And it gives you the first quartile, that's 1.9. Now, if you want the third quartile, you're going to type or choose it from the stats menu, L, 3. Right? And then if you want an interquartile range, you are just going to click on the number. See how when you click, it selects it. Copy, Control C or Command C if you're on the Mac, and then minus, and then click on the number, and Control V or Command V to paste, right? Control C, and then Control V, or Command C, Command V. And your interquartile range is 1.43. Very simple, right? The quartiles, subtract them. Always remember that the interquartile range is positive, so you always start with the third quartile and subtract the first. Now, if we had to interpret it, we would say, like if I wanted to interpret the first quartile, I would say 25% of students have GPA of 1.9 or below. Right? And then 75% above that. If I wanted to interpret the third quartile, I would say 75% of students have GPAs of 3.33 or below, and the rest, which would be 25%, have GPA higher. Now, is it exactly correct from the data? No, but this is just approximate. Okay, this is the last part. Is interquartile range resistant? What does that mean? Again, remember that the range and standard deviation are not resistant, right? So if you have an unusual observation, that is going to affect the range and standard deviation. But what about interquartile range? Can we use it as a measure of spread? Well, let's take a look real quick. Okay, so I'm going to split the screen. I am going to have the Desmos here, and let me just switch to the other Desmos where I have the data. And this is the travel to school example. Okay, so what I want to do is I want to compute the mean, the median, the standard deviation, and the interquartile range. Now, this would be the difference between the third quartile, so that would be t, 3, and the first quartile, so t, 1. Now I have all of them right here, right? Now, imagine that I messed with the data, and actually the last student's score wasn't 38. It's not the score, it's the travel time. So it wasn't 38, it was 68. So you definitely introduce an extreme observation in the data. What will happen to all these four measures? Well, let's take a look at that. Now let me actually go a little bit smaller here, so we can kind of fit everything on the same screen. So let's define another data set. We'll call it T2. Okay, so I'm going to copy this, but instead of 38, I'm going to put 68. And I'm going to recompute all the measures. So the mean, the median, the standard deviation, and the interquartile range. Let me just copy that here. I just have to insert a 2. Now, by the way, in Desmos, when you see this little subscript, I'm not doing anything. I am just typing 2 and it already understands it's a subscript. So I want you to compare the mean, the original mean, and the one with the outlier in there. It didn't change. Well, actually, yes. You see it was 20, but now you have an outlier. The mean changed to 23.3. So it definitely is affected by outlier. It's moved towards that outlier because the number became much larger, right? Now, what about the median? Well, it was 18 and it stays 18. So median is not affected. And again, remember, you should have this on your card, that the median is a resistant measure. What about standard deviation? Let's take a look. The old standard deviation was 9.08. The new one is 17.82. Did it change? You bet you. It's almost like twice as big as the original one. So standard deviation, again, is not resistant to outliers. But what about interquartile range? Well, take a look. The original interquartile range was 14, and the new one is also 14. And they're both 14, which means that interquartile range is resistant to outliers. And it should be used then if your data has outliers, okay? So, to conclude this, which measures do we want to report? This is something that you absolutely will need on your note card for the test. If your data has no outliers, then for the measure of center, you want to use the mean, and for the measure of spread or variability, you're going to use the standard deviation. Because if you have no outliers, it can be shown that the mean and standard deviation are slightly better measures, and they're unbiased, okay? They're good measures, right? However, if the data does have outliers or extreme observations, or is severely skewed right or left, then the recommendation is to use the median for the measure of center and interquartile range for the measure of variability. For example, the government, when it reports housing prices, it says median housing price. Why does it do that? Well, because Some houses are very, very expensive, and those are outliers. So your data is usually skewed right, and you don't want that to, bias your result. That's why the government would use for incomes that are skewed right, housing prices that are skewed right with outliers. The government uses the median rather than the mean.